Hello everyone. So today we are going to uh, discuss the PCD for the code forces round that was held today, educational round. So let's start with the discussion. So this is the first problem. The name of the problem is strong password. Let's understand the problem statement. So Monocar's current password on code forces is string S consisting of lowercase Latin letters. Monocar thinks that his current password is too weak and so he wants to insert exactly one lowercase Latin letter into the password to make it stronger. So Monocar can choose any letter and insert it anywhere, even before the first character or after the last character. So Monokov thinks that the password strength is proportional to the time it takes for to him to type the password. That is, if it is taking lesser time, then the password is if it is taking lesser time, then the password is weak. And if it is taking higher time, then the password is strong. So the time it takes to type the password is calculated as follows. The time to type the first character is always 2 seconds. And for each character other than the first, the time it takes to type it is 1 second if it is the same as the previous character or 2 seconds otherwise. So for example, if you are looking to this particular string A, B, A, C, A, B, A. So if you have string something like this, A, B, A, C, A, B, A. So just if I want to write down that how much time it will take me to type this particular string, then it will be for typing the first character, I will take time 2 plus for typing every other character, the time taken will be 1 if that particular character is equal to its adjacent previous character, and it will be 2 if it is not so. So for typing B, my time taken will be 1. For for typing B, the time taken will be 2. For A, the time taken will be 2 because since A is not equals to B. Similarly, for C, the time taken will be 2. For A, again, the time taken will be 2. For B, the time taken will be 2. And for A, again, the time taken will be 2. That will result out to 14. And similarly, if I am talking of password something like this, AAABACC, so AAABACC. So for this, the time taken will be, for the first character, it will be 2. And for this particular character, it will be 1, since this particular character is equal to its last adjacent character. Similarly, for this A, it will be 1. For this B, it will be 2. For this A, it will be 2. For this particular C, it will be 2. And for this particular C, it will be 1. So now if you calculate for this particular string, my password will be, my typing speed will be, or the time taken will be 8 plus it will be 11. Till now, anyone has any doubt? So what you need to do is you need to insert at exactly one character in this particular string so that the password becomes strong. That is, the time taken to type the password is the maximum possible time. So you need to insert exactly one character such that the time taken is maximum. Do anyone has any problem in understanding the question? Anyone? Okay. So now how to think of the solution? See, when I get something like this, that okay, for when I have two same characters, in that case, for the next character, I am taking time 1. Now, what maximum I can do? The maximum I can do is for typing this particular character, I will take time 2. This is the maximum I can do. If for typing a particular character, I am taking time 2, can I change the time taken to type this particular character? Do I have that facility? The answer is no. The only facility available is whenever we were typing any character whose value was equal to the last character, the time taken to type this particular character was 1. So what maximum we can do is we can just make this value 1 as 2 by inserting some characters in between. Like for example, if I have my string wait a minute. If I have my string something like this, now for typing the first character, the time taken is always 2. This is something that I already know. Now for typing this particular character, I know the time taken will be 1 since it is equal to its last adjacent character. So what I can do is I can insert some character in between which is not equal to this value a, that is something like anything between b and z. Let's suppose I insert b. So now the time taken for this b will be 2 and for this a also it will be 2. So what I am doing is I am satisfying two conditions, that the character I am adding takes time 2, and if there is at least one character that was taking time 1, so change one character to 2. That is, change the time taken to type one character to 2. So this was the logic behind this question. So do anyone has any doubt? Okay, so let's jump on to the code. So the implementation completely depends on you, how you want to implement it. This is something that I wrote during the contest. So I took the string s as input, took the size of the string in n, initialized my answer with an empty string. Now we have initialized, I have my I initialized to 0, my f value equals to 0. So this f will tell me that whether I have inserted some character in between or not. Okay. So I am simply going over all the characters lesser than n minus 1. I am not iterating till the last character. Just observe over here. I am iterating till the second last character. And now if my ith character and I plus 1th character are equal and my value of f is still now 0, this means that till now I haven't inserted any character. In this case, what I will do, I will, in between s of I and s of I plus 1, I will insert one character. So in my answer, first of all, I will add s of I. Then I will add my inserted character and mark the value of f as 1. This means that from the next character, I am not going to insert any more characters. That is from I plus 1. So to my answer, I added s of I. Now what is the inserted character that I am using? So the character that I am using is, if my s of I is equals to z, in that case, the inserted character I am taking as a, else I am taking the inserted character as the next character in the lexicographical order. That is, if s of I is b, I am taking c. If it is c, I am taking d, something like that. This is something that completely depends on you, how you want to, which character you want to insert. The only constraint is that the particular inserted character should not be equal to s of I. So you have other 25 possible options you can do. You can insert any of them. So once I am done with this, I am marking f as 1. And else, if this condition is not satisfied, that is, either s of I is not equals to s of I plus 1, or even if they are equal, the value of f is not 0. That is, the value of f is 1. That is, I have already inserted one character in between. So I can't do anything else now, because in the question it was mentioned that we can insert exactly one character. So at the end, so else I am just adding s of I. At the end, I know that since I have iterated till I equals to n minus 2, that is still the second last character. So I am left out I am left out with adding this particular the last character to my answer. So I simply added s of n minus 1. Now, if after constructing this answer string, till now my value of f is not my value of f is not 1. That is, I have not inserted any character till now. When will such thing happen? Such thing will happen when this string, the given string, contains all distinct characters. So if this is the case, so at the end, I will insert any character that is not equal to the last character. So if f is not equals to 1 till the end, so just doing the same thing what I did over here. Just inserting the character that is not equal to the last character. So if s of n minus 1 is not equals to z, so I am just inserting s of n minus 1 plus 1, else I am inserting a to my answer. And at the end, I am printing the answer string. Just tell me, do anyone have any doubt? can we just brute force for all solutions and all 26 characters? I don't think you can do so because the length of the string was given as 10. So you have total 11
అరే
possible.
ఏదో కాంటెక్స్ట్ ఎక్స్ప్లెయిన్
You have
చేస్తున్నారా?
total 11 possible options. So
బై
yeah, so
మిస్టేక్ గా మన గ్రూప్ కి
26 power
పంపించినట్టున్నాడు
11
కదా.
of kind. Can you please mute yourself, Adil? Kindly mute yourself, please.
సారీ
It's my
సారీ.
request. Which part do you want me to re-explain, Tisha? The code part or the logic part? Code part. Okay. So see, in the code, what I am doing is, if I am just keeping one variable f, and in this f, I am just, if the value of f is initialized to 0, that is till now I haven't inserted any character. Now I am simply iterating till my second last character. Why I am doing so? Because in my code, in my inner code, I am taking s of I and I plus 1. So if s of I is equal to s of I plus 1, and till now my value of f is 0, this means that I am left out. I am still left inserting the character. In that case, I am inserting the character in this particular point. So to how will I insert a character? So to my answer string, first of all, I will add si, and then I will add the inserted character. So what will be the inserted character? So if the character, the present character is anything that is not equals to z, in that case, I am just inserting the next character. But if it is equals to z, so I know that there is no next character to z in English alphabets, right? So in case of Z, I am simply inserting A. You can insert any of the characters right over here. So I am inserting one character and marking the F value as 1. This means that after this, I am not going to insert any other character. Else, if any of these two conditions are not satisfied, so I am just adding S of I to my answer. And at the end, I know that since I iterated till the second last character, so I am adding the last character. And even after adding the last character, till now the value of f is not equals to 1. This means that I had all the distinct characters in the string. That is, I have not inserted any character till now. So I will insert one character at the end. And the character that I am inserting should not be equal to the last character of the string s. So just keeping the check over here for that thing. The same thing that we did over here. For s of I, the same thing we did for s of n minus 1. And at the end, I am just printing my answer string. We can't brute force for this because you have 11 possible insertion space. Like if the value of n is 10, so you can insert either at this place, this place, this place, this place, this place. So it will form total of 11 places. And at every 11 place, you are telling that you will brute force for 26 alphabets. So in that case, you will have 26 letters at every possible position. So the total complexity will be 26 power 11, which will definitely produce TLE. So I hope this code is clear to everyone. So let's jump on to the second question for today. Okay. So looking at this question, actually, for this particular question, the additional constant which was given made this question super easy. And if anyone who had not looked to that additional constraints, that is this one, then for them, this question would be a bit tricky. So let's go through the problem statement then. So there is a grid consisting of 2 rows and n columns, and each cell of the grid is either free or blocked. A free cell Y is reachable from a free cell X if at least one of these conditions holds. X and Y share a side, and there exists a free cell Z such that Z is reachable from X and Y is reachable from Z. A connected region is a set of free cells of the grid such that all the cells in it are reachable from one another, but adding any other free cell to the set violates the rule. For example, consider the following layout where white cells are free and dark gray cells are blocked. So you can see that white cells are free and dark gray cells are blocked. So there are 3 regions in it. This is one of the regions that is marked with red. This is the another region that is marked with green, and this is the third region which is marked with blue. So it is given as the given grid contains at most one connected region. So it was written over here, but many of us, like including me as well, just ignored this line. Like I didn't pay attention to this particular line. So your task is to calculate the number of free cells meeting the following constraint. So if the cell is blocked, the number of connected regions become exactly three. Mm, kindly mute. Okay. So let's understand the question. Like I would say it was very easy. Let me make you all understand this. It is given is that you are given a grid that contains two rows and n columns. N columns. And there are some cells that are marked as blocked. Okay. There are some cells that are marked as blocked. And in the question, they have given you that you have at most one free region. Free region or connected region, what they have mentioned. Yeah, one connected region. So you have at most one connected region. Like in this case, you can see that there is one connected region. There can be the case something like this as well, where all cells are blocked. So there are zero connected region. You can't have something like this. According to the question, you can't have something like this. That you have this. In the question, yeah, this also works. So you can't have something like this according to question, because if you have something like this, then you see you have two connected regions. This is one connected region and this is the other. And in the question, it is clearly mentioned that you have at most one connected region. Okay. So now the question wants you to answer that if you have something like this, then just tell me how many free cells are there such that when I block that particular cell, the grid gets divided into exactly three connected regions. By connected regions, we mean that a free region. That is, if let's suppose you have grid something like this cell is blocked and this cell is blocked. So starting from this cell, you can reach this particular cell and this particular cell. So this forms a connected region. Starting from any of these cells, you can reach to any of these cells. So this forms a connected region. But since these two cells are blocked, so starting from this particular cell, you can't reach to this particular cells, any of these particular cells. So I will say that they belong to different connected region. That is, one free region form one connected region. This is what we mean by connected region. Okay. Now how to solve this? So one thing that you all should be clear with, that if I am talking of three connected regions, exactly three connected regions at the end, so what are the possibilities that I can have? And if you try to think in that way, that what are the possibilities that I can have, the things become very clear. The only possibility that you can have is if this particular cell is blocked, if this particular cell is blocked, and if this particular cell is blocked. Only in this case, you have three connected regions. If you observe, only in this case, you can have three connected regions and no other case. And similarly, the like inversion of this also exists. Like this case. In this case also, you will have three connected regions. So whenever you encounter a free cell, let's suppose this was the case initially given to you, which has, in this case, one connected region. Let's suppose this was the case given to you, and I say you that this is a free cell. Just tell me if by blocking this cell, I can get exactly three connected regions or not. So in that case, I will just check that if this is with I equals to 0, then it's this particular cell and this particular cell, that is I plus 1 comma j minus 1, if this is I comma j, and I plus 1 comma j plus 1. If these two cells are blocked or not. And this particular cell should be free as well. So I plus 1 comma j should be free. If this is the case, so I can say that blocking this particular cell will lead me to divide this entire region into 3 connected spaces.
Excuse me, sir.
Yeah, let me complete. Just a minute.
Okay.
But you should not have something like this as well. That this is one blocked, this is one blocked region, and let's suppose these all are blocked. So in that case, for this particular cell, I will not say that blocking this particular cell will lead me to like, since this particular cell is also blocked, this is free, this is blocked. So I will not say that blocking this particular cell will divide this into exactly 3 connected regions, isn't it? So for a free cell to meet all the conditions, that is, on blocking this free cell, my entire grid gets divided into 3 connected regions. Its adjacent grid should be free and these grids should be blocked. If this particular case is there, then in that case, I can say that on blocking this particular free grid, I can satisfy the condition, and hence I will just add 1 to my answer. Now the ones who are facing problems in connected region, so this is what we mean by connected regions. That is, if you have any free cell, that is, let's suppose this particular cell is blocked, this particular cell is blocked, and this particular cell is blocked. So starting from this cell, I can reach to which cells? I can reach to this cell, this cell, this cell, this cell, this cell. No? So this all lies in one connected region. Similarly, starting at this particular free cell, I can only reach to this particular cell only. So this cell forms one connected region. So this is what we mean by connected region. Yeah, the one who was asking the question, kindly continue.
Excuse me, sir. So like what I did was, sir, like I just tried to brute force it for every possibility, and whenever I encountered a blocked cell, I would like whenever I encountered an open cell, I would like block it and then count the number of components for it. Like the general approach, if it was an in matrix, then what we would have done was that we can find the number of components by blocking and blocking the all the unlocked cell, and then finding the number of components using the traversals. But so it was giving TLE as it was order of n square for that.
Like for a particular free cell, what you are doing?
So for a particular free cell, I would like block it and then count the number of components that were present in the graph.
Okay, just tell me, for finding the number of components, what is the time complexity it will take you for finding the number of components?
So for finding the number of components, it would take
You will require one DFS or BFS traversal, isn't
yes,
it?
so one
So
one DFS
it will
traversal.
take n multiplied by 2 time complexity. That
Yes,
is
sir.
the total number of cells.
Yes,
And
sir.
since you are checking this for each and every cell, so you have n cross 2 cells.
Yes, sir.
So the total time complexity would be big of n square, right?
Yes, sir.
So it would give TLE. So it will not work.
But sir, if it was an enclosed matrix, then how would we have done that?
Then the constraints would have been something different.
Yes.
Like, let's not talk on that thing now.
Okay.
Yeah.
So like if it is in this case it is an enclosed 2 matrix, so we don't have to use the generalized approach for
No,
that.
no, no. It's not needed.
Okay.
Yeah. So anyone else
Sir,
having any doubt in the logic? Yeah.
yes sir, I
Continue.
would have. सर लेट्स से आप बोले कि जो एडसेंस है राइट लेफ्ट और डाउन वाले वहाँ पे ओपन होना चाहिए एंड जो डायगोनल एलिमेंट्स हैं वो क्लोज होना चाहिए राइट
Yes, I say that for this particular free cell, this should be open and this should be closed. Yeah.
बट व्हाट इफ अगर उसमें से कोई सा भी मतलब लेट्स हम लोग को जो गिवन इनपुट है उसमें ऐसा कहीं पे है ही नहीं कि मतलब दो अल्टरनेट ब्लॉक्स जो हैं वो ब्लॉक्ड हों ऐसा कहीं पे है ही नहीं तो फिर
Then your answer will be 0, no?
नो तो आंसर तो सब 3 होना चाहिए ना बिकॉज अगर हम लोग 3 सेल्स को ऐसे ब्लॉक कर दें तो
Which three cells you're talking about? Can you just give me a, like, if I'm marking
Let's
this
say
as
in input,
1,
let's
2,
say in input
3,
we have,
4, 5, 6, 7, 8, 9, 10. Just tell me the blocked cells.
yes, let's say the given input is no cell is blocked, right? Then if
Okay.
we block the seventh cell, third cell, and ninth cell.
No. At a time, you can only block one cell.
Acha, okay, at a time we
Yeah.
can only block one
Individually, you
cell.
need to answer the question.
Okay, sorry, sir.
Yeah. Okay. So let's jump onto the code now. So the implementation part again, like, because since in the since in the contest, I just override this condition. So I was writing something very bad, and from there I wrote this thing. So let me just explain you this thing, but you all can just write it by yourself also. The only thing that we need is that for a greed, for a free cell to contribute to the answer, its all adjacent cells should be empty and its diagonal cells should be blocked. That's the only condition that you need. So what I did over here is I am just iterating over each cells. So I equals to 0, I less than 2, I plus plus, j equals to 0, j less than, and j plus plus. If v of I of j is dot, that is, it is free. In that case, I kept one temp variable initialized to 0, and I am just checking that if my side adjacent cells are empty or not. So if j plus 1 is less than n and v of I of j plus 1 is equals to free, in that case, I am incrementing my temp. Similarly, if my left cell exists and it is empty, in that case, I am incrementing my temp. So if after these two steps, my temp is lesser than 2, that is, either I don't have side cells, or even if I have them, they are blocked. In that case, I know that I can't block this particular free cell that I am in. So in that case, I am simply continuing. Else, if this is not the case, that is, I have two adjacent side blocks and they are free as well. In that case, I'm just checking if my value of I is 0. If my value of I is 0, that is, if I am in the top row, so I need to check these particular cells are blocked or not, and this particular cell is free or not. This is the condition I need to check. So if I is equals to 0, so if v of I plus 1 of j is equals to dot, that is, it is free, and diagonal cells, that is, I plus 1 j minus 1 is not equals to dot, and I plus 1 j plus 1 is not equals to dot, that is, both of them are blocked. In that case, I am just incrementing my answer, which I initially initialized to 0. And similarly, if I was not equals to 0, that is, I was equals to 1, that is, I am standing at the lower row. So just I am checking for the upper row. So upper row diagonals. So if v of I minus 1 of j is equals to free cell and the upper diagonals are not empty, that is, they are blocked, in that case, I am incrementing my answer. And at the end, I am printing my answer.
Excuse me, sir.
Yes.
Sir, for example, if we were not given the condition that at most one was there, then how should we have approached the
Uh,
problem?
let's not go into that, because for that, after blocking every cell, then we need to look for the possibilities. Like, I was doing something like that initially. It took me around 30 minutes to figure out what we actually need to do. And at the end, I saw that, okay, that was also not working. And then I saw that we have one constraint given in the problem.
Yes, sir. Actually, I also was doing the same thing.
Yeah. So let's not go that way. It will become a bit tricky. Test case 4. This particular test case, yeah, I can. Let me try run it. Dot, wait a minute. Yeah, dot, 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 star. And for this, we have two dots. So can I say that for this particular test case, if I am blocking this particular cell, or I am blocking this particular cell, in that case only, I will be divided into 3 regions. Like, I will show you for this particular cell. If I block this particular cell, so see how many connected regions I have. This is one connected region. This is one connected region. And this is, sorry. And this is one connected. The fourth one, okay. 1, 2, 3, 4. This is only the fourth test case now.
सर बोल रहा है कि फोर्थ वाले को ब्लॉक करेंगे ना कि लास्ट सेकंड वाले को.
Fourth free one, not the last one.
लास्ट सेकंड वाले का राइट वाला तो एक्स है ना, तो उसको कहाँ से ब्लॉक कर पाएंगे?
Which one are you talking? Like in this test case only, you all are
हाँ,
talking.
फोर्थ टेस्ट केस में सर जो
हाँ सर, वो जो राइट
रो
वाला
है,
जो रेड
सेकंड
है,
रो का जो लास्ट कॉलम है ना, लास्ट कॉलम के पहले वाला. सर आई
Second
की
row
वैल्यू
क्या?
1 ले लीजिए, आई की वैल्यू 1 ले लीजिए और जे की वैल्यू
1, 2, 0, 1,
हाँ
2,
7.
3, 4, 5, 6, 7, ये वाला.
हाँ हाँ, तो जो 7th वाला है उसको ब्लॉक नहीं करेंगे ना, क्योंकि 8th वाला तो एक्स है ऑलरेडी.
Yeah, we can't block this particular. Okay, we can't block this particular cell. Yeah, sorry.
थर्ड वाले को करेंगे. आई
Yes,
की वैल्यू 0 एंड जे की वैल्यू 3.
sorry for that. So you can just figure it out. Yeah. Yeah, we can block this particular. No?
Yes.
The adjacent is empty. Yeah, we can block this particular cell. So there are two cells that you can block. This is something that you can figure it out. Is the logic part clear? How we can think of this? Okay, so let's move on to the third question.
Sir, we can also block.
Yes. Yes.
Sir, we can also block the first row and the third column.
First row and the third column. Third column is already blocked now.
So first row and third column.
This is the first row and this is the third column. You are talking in zero-based indexing?
Yes, sir.
Yeah, these are the only two cells that we are blocking. First 1, 3 and 1, 5. This is something that we can't block.
Okay.
Yeah. Yes, you can think of any other approach, Kumari. Like this is something that I cracked out during the contest, and like I can't think of any other approach as of now.
sir, please repeat the approach once.
The approach is that for any free cell that if blocked can divide the entire grid into 3 connected regions, its adjacent cells should exist and should be free, and that is it has 3 adjacent cells, right? So its adjacent cells should be free and it should exist, and its diagonal adjacent elements should be blocked. This is the only case when we are able to divide our grid into exactly 3 connected components. This is one connected component, this will form one connected component, and this will form a join. This was the approach, if I summarize it. Okay, so let's move on to the third one. So the name of the question is even positions. It was relatively more easy. So let's go through the problem statement. Monocorp had a regular bracket sequence S of length n, where n is even. So he even came up with his own way to calculate its cost. He knows that in regular bracket sequence RBS, each opening bracket is paired up with the corresponding closing bracket. So he decided to calculate the cost of RBS as the sum of the distances between pairs of corresponding bracket pairs. Like for example, if I explain with this particular example, so if you have this bracket sequence, this regular bracket sequence, so for this, the cost will be, if you consider every pair, like this is one pair of closing and opening bracket. So if you simply subtract their position values, like this is position value 1, 2, 3, 4, 5, 6. So if you simply subtract their position values, this is position 1, 2, 3, 4, 5, 6. So there are one pairs with position value 1 and 4, one pair with position value 2 and 3, and one pair with position value 5 and 6. If you simply subtract them, it is 4 minus 1, which is 3, 3 minus 2, which is 1, and 6 minus 5, which is 1. So if you simply add these values, 3 plus 1 plus 1, so that is something will be the cost of this particular string. That is the cost of this regular bracket sequence. So unfortunately, due to data corruption, Monocorp has lost all characters in odd positions and only characters on even positions remain. It was something that was not required for this question, that on which character position the characters are lost. Monocorp wants to restore his RBS by placing brackets on the odd position, but since the restored RBS may not be unique, he wants you to choose one with minimum cost. It's too hard to do for Monocorp alone, so can you help him? Reminder is that a regular bracket sequence is a string consisting of differences. Okay. So let's understand the question. The question is that initially you have a regular bracket sequence. Initially Monocorp has a regular bracket sequence, something like this. Okay. And now what happens is he lost all the characters that are present at the odd positions or even positions. Let me see. Yeah, all the characters in the odd positions are lost. So this position character is lost, this is lost, this is lost. So he is left out with something like this. This is a blank, this is a blank, this is something like this is a blank, and this is something like this. Now, what he wants you is that you fill up these characters such that the cost of this string is the least minimum as possible. Cost of this string is least minimum as possible. And what is the cost? The cost is that if this is a sequence, so just take out the pairs of opening and closing bracket. This is one pair, this is the other pair, and this is the other pair. Simply subtract their position values, 6 minus 5, 3 minus 2, 4 minus 1, and just add those differences. 3 plus 1 plus 1, which is equals to 5. So for a string, this is the cost. And now what, due to data corruption, since all the characters at the odd positions are lost, so you need to fill up these characters such that the cost is minimum. So there are like two ways to fill this string. The starting character will always be 1. This is something that I know. The starting character should always the starting character should always be a opening bracket. This is something that I know. Then this is opening bracket. Now what I can do is I can place an opening bracket over here and keep these 3 closing brackets at the end, or something that I can do is at this particular position I can simply place a closing bracket and place an opening bracket over here in this particular empty position. So these are the 2 possible strings that can be formed by the given string. So the question is that which one of these has the minimum cost? So let's calculate for these 2 strings and then we will extend our solution for any general string. For these 2 strings, what is the cost? For this particular string, what is the cost? Let's calculate it. This is position value 1, 2, 3, 4, 5, 6. So for this particular pair, the cost is 1. For this particular pair, the cost is 3. And for this particular pair, the cost is 5. So the total cost comes out to be 9. Similarly, in this particular string, for this particular pair, the cost is 3 minus 2, that is 1. Plus the cost for this is 4 minus 1, which is 3. And the cost for this particular pair is 6 minus 5 plus, which is 1. That comes out to be 5. So through which particular combination we got the least value? Through this particular string, isn't it? Yeah. So what is the logic that we are going to follow? See, if I simply tell you that you have something like this, you have a lost character over here, and you have some characters over here. Some are lost and some are like fit. Some are lost and some are fit. Let's suppose you have something like this. I am not just seeing the combination as of now. Just ignore that thing. I just want to figure out that whatever is there over here, whatever characters I have towards the right, what is the character that I will try to fill in this particular blank position. What particular character I will try to fill. So what I claim to you all is that whatever character I have at the end, if I have a close opening bracket towards the left that is not yet closed, in that case, I will just fill a closing bracket over here. Simarjit, kindly mute yourself. Yeah. So if there is any blank space over here and we have an opening bracket in the left hand side that is not yet closed, in that case, I will place a closing bracket right over here. And why I am making this claim? Because see, if I have these two opening brackets which are not yet closed, isn't it? So this will be at some position 1 and this is at position 1 and this is at position 2. So I know that if I have these two opening brackets, so this is the first bracket that is going to be closed and then this particular bracket will get closed. Now, if I want to take the differences between the positions of opening and closing bracket for a particular pair, so can I say that it is good for me that as soon as I find a pair for this particular bracket, it is good for me? Because at the end, whatever position this particular opening closing bracket exists at, so what you will do, you will simply calculate this value now, I minus 2. You want to minimize this value. So what you will want? You will want this I to occur as soon as possible. So what I claim is that if you have an opening bracket that is not yet closed, in that case, if you have a blank space, you will put a closing bracket right over here. But if you have something like this, and now you have a blank space, that is, you know that you don't have any opening brackets to be closed. In that case, you don't have any option. You have to put the opening bracket over here. So this was the solution for this question. Just fill the string character, something like this, and then at the end, you can just calculate that particular cost. No, the stack approach is also not needed because you know that in this case, there will be a regular expression for, like there will be a regular combination of these parentheses formed. You don't have to take care of that. The only thing that you need to take care is that if you have a opening bracket at the left, which is not yet closed, in that case, just insert the closing bracket in the blank position. And if you don't have any opening bracket in the left side of the blank position, in that case, just put an opening bracket over here. This was the logic for this question. A greedy idea, I would say. Anyone having doubt in the approach? Should I jump to the code? This is actually not a class, Nitesh. It is actually a post-contest discussion. Your classes will start from 3rd. Okay, so let's jump on to the code. So what I did, I took the input of n and string s, initialized my count to 0. So just iterated over all the characters of the string. If my ith character is an opening bracket, so in that case, I am simply incrementing the count. If my current character is a closing bracket, in that case, I am simply decrementing the count. So by incrementing count, this means that I have one opening bracket that is not yet closed. If I am getting a closing bracket, I am just decrementing the count. That is, for one of the opening brackets, I have already got a closing bracket. Else, if it is not an opening bracket as well as not a closing bracket, in that case, I am checking that is my count greater than 0. If it is, this means that in the left hand side, I have one opening bracket. I have at least one opening bracket that is not yet closed. So in that case, in the ith character that is in the blank space, I am putting a closing bracket and decrementing my count. Else, if I know that my count is not greater than 0, that is, it is equal to 0, that is, I don't have any opening bracket in the left hand side of this particular blank character, then in that case, in the blank character space, I am putting an opening bracket and incrementing my count. So once I am done with this, I know that my string s is a string that will produce the minimum cost. So the only thing now I need is to calculate the cost. So that is something that I can do easily, that if I have a string with me, and I tell you to calculate the cost of this, so what you can do? If this is index 0, 1, 2, 3, so if whenever you get an opening bracket, just push them in the set. You get 1, just push them 1. Now I get 2. So I know the last opening bracket that I got was present at index 1. So just add 2 minus 1 to your answer. And simply remove 1. Now you go to 3. So again 3 is a closing bracket. So just add the just to calculate this value, 3 minus 0, that is 3, and add it to your answer. So by maintaining the set, you can achieve this. Let me explain this once again via this example. It is 0, 1, 2, 3, 4, 5. So you have a set. Yeah, you can use stack, you can use set, you can use any of these. It's not a matter. What I used during the contest or what I wrote in the code, that is something that I am trying to explain you all. To calculate the cost of this particular string, there are many ways that you can apply. It completely depends on you. I am explaining the one that I coded it down. The logic remains the same. So I get an opening bracket, I push 0 in my set. I get a closing opening bracket again, that is at index 1. I push 1 in my set. Now I get a 2. So the last character in my set is 1. So I simply calculate 2 minus 1 and add it to my answer and simply erase 1 from the set. Again, I get a closing bracket. So I simply add to my answer 3, that is the index of this closing bracket, minus the last character in this set, which is 0. Again, this gets removed. Now again, I get an opening bracket. I simply add it to my set. Again, I get a closing bracket. So to my answer, I simply add 5 minus the last character in my set, that is 4, and simply remove 4. So all these things will contribute to my answer. And at the end, I can simply print my answer. So wait a minute. Yeah. So this is the code I wrote. Initially initialized my answer to 0, just constructed a set, initialized my answer to 0, went to each and every character of the string. If the character is an opening bracket, in that case, I am inserting the index of that particular character in my set. Else, just taking the last character of the set. So last character of the set is something that we can write like this to take the last character of the set, that is the R begin character. By R begin, we get the last character. You can do something like that also, st.end minus 1. That will also give you the last character. Even R begin will give you the last character. So just taking the last character to my answer, adding I minus that last character index value, and just erasing that thing from my set. Once I am done with this for each and every character, so just printing the answer.
Excuse me, sir.
Yes.
Sir, can you please explain why does the greedy approach works here? Sir, because for example, when you told the first case where opening bracket, and then after that we have to place only the closing bracket.
Yes.
Couldn't it be the case like if we place the closing bracket just after the opening bracket, the final sequence wouldn't be like the net sum is 0, like net
No,
brackets are
it
unclosed.
no, net sum will always be 0, because when I am putting this closing bracket over it, when I have an opening bracket in the left hand side that is not yet closed, isn't it?
Yes, sir.
So the net sum will always be 0, na?
So like
Like
yes, sir.
like if you have something like this, 2 opening brackets. So, and let's suppose you have 3 opening brackets. Now I tell you that you need to put 3 closing brackets to make this sequence a valid sequence, isn't it? You need to put 3 closing brackets. Now, what are the options you have? At this particular place, you can put 1 closing bracket. At this particular place, you can put 2 closing brackets if you have not put a closing bracket anywhere before. And at this particular place, you can put 3 closing brackets if you have not put closing brackets before. So how you are getting this value 3, 2, 1? By the number of opening brackets in the left hand side that are not yet closed. So if I tell you that I have 2 opening brackets in the left hand side and I have a blank character over here, so I can put a closing bracket anyhow, no? It will not be a problem for me since I have an opening bracket in the left hand side. It will close one of the opening brackets, that's all.
Yes, sir, got it.
Yeah, so the string will always be balanced. It will not be an issue.
Sir, can I ask something?
Yes.
Sir, in the code part, what is the debug thing?
That is, just ignore that part. That is for for checking what the string I got at the end. I have one function defined and
Sir,
just
can you please show that?
no, this is something that that I can't show right here. It is something that is there in my compiler. I have defined a debug function over there. This is something commonly used for debugging the codes. So yeah, you can ignore this part of code. It is not necessary. Okay. So let's move on to the last question for the day. Yeah, the create string is that if I am getting an opening bracket, I am incrementing my count. If I am getting a closing bracket, I am decrementing my count. And if I am getting a blank character, in that case, simply I will check that can I put a closing bracket over here. So how I will check that if I can put a closing bracket or not? By just seeing the value of count. If the value of count is greater than 0, this will imply that I have an opening bracket that is not yet closed. So in that case, I am just putting the closing bracket and decrementing my count. That is, I decrementing my count because I have put a closing bracket for one of the opening brackets. So one of the opening brackets is blocked. So decrementing my count. Else, I am putting a closing opening bracket. And since I have an opening bracket, new opening bracket, I am incrementing my count. That is, I still have a bracket that needs to be closed. Yeah, please mute yourself. So yeah, this was the logic for the first part. Or entirely the third question, actually the completely greedy logic. Yeah. So let's move on to the fourth question. Oh, wait a minute. Yeah. So the name of the question was maximize the root. Let's go through the problem statement. You are given a rooted tree consisting of n vertices, and the vertices in the tree are numbered from 1 to n, and the root is the vertex 1. The value ai is written in the ith vertex. So you can perform the following operation any number of times. Choose a vertex v which has at least one child, increase the value of av by 1, and decrease the value of au by 1 for all vertices u that are in the subtree of v except v itself. So however, after each operation, the values on all vertices should be non-negative. That is, or after each operation, the value should be greater than equals to 0. So your task is to calculate the maximum possible value written at the root using the aforementioned operation. N is of the order of 2 into 10 power 5, AI is of the order of 10 power 9. And you have, okay, we will see the inputs, but let's first of all understand the question. It's actually the easier one if you understand the question well. A very easy question if you understand the question well. See, the question they have in the question they have given that you have n vertices in the tree. And they have also given the root of the tree. That 1 is the root of the tree. So you have tree something like this. Okay, you have tree something like this. Now they have also given you the value for each and every vertex. That what is the value for this vertex, what is the value for this vertex, what is the value. Okay. Now if I simply just write down the values over here instead of writing the node number. If I simply write down something like this, that it has a value 4, it has value 5, it has value 6, it has value 9, it has value 3. Okay. So what are the operations that you can do? The operations that you can do is if you are, let's suppose, standing at this particular node. So you can increase the value of this particular node by 1. But once you are doing this, all the nodes that are in the subtree of this particular node will get reduced by 1. I repeat, if you are standing at this particular node and if you increase the value of this particular node by 1, so all the nodes that are in the subtree of this particular node 6 gets decreased by -1. That is, their values get decreased by -1. So if I make this value as 7, this value will become 8 and this value will become 2. if I let's suppose say you that this is the only tree, this is the tree that I have, that this value is 6, this value is 9, this value is 3. Can someone say me what is the maximum value of this particular node can I get?
9.
9. Why? Because if I make this 7, it will become 8. This will become 2. If I make it 8, that is increased by 1, it will decrement by 1, it will decrement by 1. Now, if I increase it by 1, it will become 9, it will get decremented by 1, so it will become 6, it will become 0. Now, I can't decrement the value of this particular node more. So, at the max, the maximum value of this particular node that I can obtain is 9. Is everyone clear with this?
Yes, sir.
Is everyone clear with this? So, this part of question is done. So this part is understood, that what is written in this part, that you can perform following operation any number of times, choose a vertex V which has at least one child. Okay. So if I am performing any operation to any of these vertex, so it should contain some child now. That is mentioned, that it should contain some child. Then only it is possible. You can't perform these operations to this leaf node. So yeah, so increase, if you have a vertex V which has at least one child, increase AV by 1 and decrease AU by 1 for all vertices U that are in the subtree of V except V itself. That is, for V, the value will get incremented by 1, and for all other nodes in its subtree, the value will get decremented by 1. And after each operation, the values on all vertices should be non-negative. That is, if any of the node in the subtree, no, we can't increment the value of leaf node as well. So if any of the node in the subtree has value 0, once you have that, so you can't perform any other operation. Now the question is that you need to, by doing such operations, you need to maximize the value of the root node. So your aim is not to maximize any other vertex. Your aim is to maximize the value of root node. So like many of you would have a thinking that, okay, you are telling me that you have node something like this. You have node something like this. You have node values something like this. Why not you are doing something like that? That, okay, find a minimum in the subtree. The minimum value is 3. So just increment this value of 6 by 3. That is, make it at 9. Make this as 0. Make this as 3. Even if you are not making these 0 and 6, it is understood. But make this value as 9. But just try to think. If I do something like that, I make this value as 9. So once I make this value 9, this particular node value will become 6. This particular node value will become 0. Now, if I try to increase the value of the root node, will I ever be able to do that? No, because in the subtree of this node 4, I have a node that has the value 0. So I can't decrement the value more. If I can't decrement, I can't increment the value of root node. So I have to keep a win-to-win situation, that I have to keep something like this, that, okay, if this is the root node, whatever value it has, if this is a tree that I have, this value is 6, this value is 3, this value is 9. This value is, let's suppose, 1. Wait a minute. Okay. Four, 6. Let's suppose 7. Okay. Now, many of you would argue that, okay, why you are not doing something like this, that for 4, for the root node, whatever is the minimum value in the subtree of this 4, just take that and increment the value of 4 that many times. Just do this. Why are not doing something like this? Many of you would argue with me. But I would reply by saying that there is a better option as well. There is a better option as well. For this particular case, okay, I would say that you can do the same. But for this particular case, just tell me, if I do something like that, will it be suitable or not? Let's suppose I have value 4 over here. Let's suppose I have value 7 over here. Then I have value 1 over here. I have value 6 over here. I have value 4 over here. Okay. Now if I tell you that do the same thing that you were telling me. Take the minimum of the nodes present in the subtree. The minimum value is 1. Increment 4 by 1 and return me 5. And you will get wrong answer. If any one of you would have tried, you would have got wrong answer. Yeah, I have these in the comments. Why I am getting the wrong answer? Because see, I have option something like this as well. What I can do? I can make this value as 2. I can make this value as 3. And now I can add 2 value to my 4. 4 plus 2, that is 6. So 6 one is better, right? Max is 8. How 8? How 8, Banu? You can't decrement 4 further, because if you decrement 4 further, this value also becomes 5. Now if you decrement 4 further, it will become 2. It will become 3. But again, now if it becomes 2, you can't decrement more than 2 from the subtree. So the win-to-win situation was, when it had the value 4, we had the value 1, make this as 3 and, sorry, make this as 2 and make this as 3. So this was the condition where many of you would have failed. This is one of the conditions where you can get a better answer over here. So now the question comes is that how you can code it down. The logic is clear that, okay, if I have some value, so what is the logic? If I say, what is the logic? The logic is that if I, let's suppose, have
multiple sir, can we made multiple operation in the nested subtree if we have a nested subtree present there, or we
what
have
do
to
you
just
mean by nested
sir,
subtree? This
sir,
particular subtree.
or no sir, we have to multiple levels in the vertices, or we have to just find the minimum from the leaf node and then update the node. I was confused in
No.
it, sir.
If for a particular node we are
Yes, sir.
incrementing its value is by 1, so
Yes,
all
sir.
the nodes that are present in the subtree will get decremented by 1.
Yes, sir, will decremented by 1.
Yeah, not
Sir,
only the
in the
leaf
case,
nodes.
sir, in the case when we have multiple levels in the subtree, then what we have to do is to
Uh,
do with the leaf node, we have to find the minimum and then update the root, or at each level we have to update. That is I am asking, sir.
for finding the answer, or like
No,
for
sir,
what?
yes, sir, for each operation you are asking about.
Like, can you take an example? I can't get your question actually.
Sir,
Let's suppose,
in an example, sir, we have a subtree which had 3 levels.
okay,
Sir, in
like
this, sir,
this
we
will
have,
work, right?
yes, sir. Yes, sir, one more level in the
Okay,
right subtree.
okay.
Yes, sir. Sir, at each node we have to apply the same operation, or we have to just go through the leaf and just find the minimum and then update the root of the
You
subtree.
can apply the operation at any of the nodes you want. It's
Yes,
up
sir.
to you. If
Okay,
you are
sir.
applying the
we can,
operation at this particular node, then
yes,
these
sir.
values will get decremented by 1 and this will get
Okay,
incremented by
sir.
1.
Sir, in
And
the case in
after,
the last subtree we have to apply, then answer will also be same. Sir, in the rightmost subtree, sir, which have 2 nodes, sir.
yeah,
Then also the answer remains same.
no,
Yes, sir.
this is
That's the
something
thing
that
I
I
was
explained.
asking.
Let's suppose this value is 6, okay? This value
Yes,
is
sir.
5, this value is 1, this value is 3, okay? Now, if I
Yes,
don't
sir.
apply any operation in this particular node and I simply apply operation in this particular node, just tell
Yes,
me
sir.
the
Yes.
maximum value that I can increment.
Sir, we can achieve 7
Yeah,
maximum.
at max you can achieve 7, but if I
Yes,
apply
sir.
operation at this particular node first,
Yes,
make
sir.
this
Yes, sir.
value 2, make this value 2. Now, if I
Okay.
tell you that what is the maximum value that you can achieve for this particular node, what you will answer?
Okay.
You will answer 8, right?
Yes, sir. Same thing I was asking about.
Yeah, this is it.
Yes, sir. Okay. Okay. Thank you, sir.
Yeah. So we need to think something that, okay, if we have a node that is having the minimum value, why not just give some value to that particular node? That particular node is lying alone. Why not give that node some particular value? So if I, let's suppose, have this node, this is the minimum of all these. Now, if I tell you that this particular node has a value 1, and I tell you that, hey, just try if you can give some values to this particular node. what you will do, what you will tell, you will tell that, okay, I am willing to give some values to this particular node, but the condition is that I should have some values in the subtree as well. I should have some values in the subtree as well. And I also should think of this particular root node, that at the end, I want the maximum value at this particular root node. So if I have some node that has value 2 right over here, and I have some node in its subtree that has the value 10, so my aim would be to make this value as 6 and this value as well as 6. If I do something like that, then for this particular root node, I will get the minimum value as 6. Instead of getting the minimum value as 2, I will get the minimum value as 6. What I told is, if I have a root node that, let's suppose, has any value, and I have 2 nodes in its subtree, one node has a value 2 and the other node has a value 10. Now, if I tell you that I want to maximize the value for this particular node, so what I will tell? I will tell that, okay, I will give some values to this particular node that is having value 2, but keeping in mind that I want to maximize the end result for this 5. So how much value I will give to this particular node? I will give this particular node the value 4. That says that this value becomes 6 and this value also becomes 6. If something like that happens, then the final tree will be something like this. And from here, the maximum value you can add to this particular 5 is 6. And 11 is the maximum result that you can achieve. This was the logic behind this question. Now, if I tell you something like this, that you have a tree, something like this. Now, if I tell you try to give 2 some value, will you be able to do that? Will you be able to do that? To give 2 some any value? No, no. You can't give 2 any value, because the behavior of 2 is that it can only give the values, it can't take. So we can't give. Sorry to this 2. Okay, we can't give any values to this 2. So now the logic is building. That, okay, till here, let's suppose I get that from this particular subtree, the minimum value is mini. Okay. From this particular subtree, the minimum value is mini 2. And this particular node has some value, let's suppose VAL. So what will I try? I will first of all calculate the minimum of mini comma mini 2, because that is the maximum number of operations I can perform in this val. So mini 1, let's suppose this is mini 1, this is mini 2, and let's suppose we calculate mini. Mini is the minimum of all the values in the subtree. So mini equals to mean of mini 1 comma mini 2. Now, if this particular value is lesser than the mini value that we got, then we can contribute something to this value. And how much we will contribute? Or if I just reverse the question, how much will I return from here, the minimum value? Are you all
mini
getting?
plus val by 2.
Yeah. Are you all getting that these two are the same questions? The first question that I made is that if this value is lesser than the mini value, then what is the value that what is the final value that I will make for this particular node? The second question that I made is, what is the minimum value that you are going to return from here? What actually matters to us? The value that we are making for this particular node, or the value we are returning from here? What actually matters? What actually matters to us? The value that we are returning, the value which we are returning. So can anyone guess the value that we are returning? If this node has a value 2 and this node has a value 10, so what we agreed upon? We agreed upon that we will be returning the middlemost value. That is 6. That is something 10 plus 2 by 2. So we will be returning val plus mini by 2. Else, if this was the case, that the value of the subtree was, let's suppose 5, and the minimum value that we got was 4, so I know that I can't add anything to it. If I try to add anything to it, I am making loss of myself. Why to make loss of myself? If I am adding, I will make this value 3, I will make this value 6. Then for the root node, the maximum that I can add is 3. But if I am not doing this operation, then in that case, in the root node, the maximum that I can add is 4. So that's the reason, in case if my value is greater than equals to the minimum value that I got, in that case, I will return this minimum value only and will not perform any operation on this particular node. Why I am returning the middle value? Because if you have something like this, so for the root node, you want the maximum value that you want to add. So if you have the value 2 over here, you don't want to add 2. You want to add something greater than 2. You make this value 3, you make with this value. Let me explain it here. You have 2, you have 10. Make this value 3, make this value 9. Now to the root vertex, the maximum that you can add becomes 3. Now make this value 4, make this value 8. Now to the root vertex, the maximum that you can add is 4. Make this value 5, make this value 7. The maximum now you can add is 5. Make this value 6, make this value 6. The maximum that you can now add is 6. But once you make this value 5, this value 7 and this value 5, now the maximum that you can add is 5. So you can't add greater than 6. So we agreed that, okay, we will meet at the middle point and then we are going to return that value. So this was the logic behind this question. The implementation was super easy. And the logic is also easy if you understand the question well. Isn't it? So let's jump onto the code. So you have n nodes. What I did is I constructed a adjacency matrix. Adjacency list. Then we have a vector in which for every node I am taking what is the initially assigned value for that particular node. Then in the question, if you observe, we are given the parent of each and every node from 2 to n. So since I am taking my inputs in zero-based indexing format, so I started with node 1. I will end my nodes at n-1, and the parents that I am getting, I am decrementing it by 1. That is, I am just converting it to zero-based indexing format. And in adjacency of P, I am pushing back I. So this is how
So
I
can you
constructed.
explain this again?
Yeah, I can. If I tell you that this is a tree given to you, so inputs will be given something like this. So you will be given 2 inputs. That for 2, the parent is 1. For 3, the parent is 1. This is something that will be given to you in the inputs. So what I do is I construct tree something like this. That is in the 1-based indexing format. So what I tell is that, okay, for this particular node, it is 0. That is 0-based indexing format. I simply decremented my parent with 1.
Okay, sir.
So at the end, I will have in my adjacency of 0, I will have 1 and 2 as pushed. Adjacency of 1 will remain empty since it does not have any child, and adjacency of 2 will also remain empty. This is the final thing that I am constructing for this particular thing. And I started my node from 1. Instead of starting from 2, I am starting with 1. If you observe over here in my code, I am started with I equals to 1. So I am taking the parent for it, converting to zero-based indexing format. You can continue with the 1-based indexing format as well. That's not an issue. This is something that I wrote during the contest. In my adjacency of P, then I am pushing back I. Then initialized my answer to 0. And this is the lambda function that I wrote. Okay. How many of you don't know this, something like this, lambda function? You can write a simple function as well. Writing lambda function, what it helps is that if I would have written, if I would have written a normal function, just imagine the things I would have need to pass. I would need to pass the adjacency matrix as well with the node, isn't it? I need to pass this answer variable as well as reference. But even if I don't pass it, this answer variable does not matter actually. I am not using it actually. So leave this answer variable. But I would have required to pass this adjacency matrix as well. So instead of just extending that thing, instead of passing so many things, what I did, I made a function within this solve function only. so that I can use this adjacency matrix from from outside. So let me explain it in short, how actually we write lambda functions. You all can just pick up any of the article of DFG and just look how do we write lambda function. They are exactly the same as the normal function. Everything is same, only the syntax wise it's a bit different. So this is how we write. We write a keyword function, then we write the return type. This is actually the return type of my function. Then we write the parameters actually that we are passing to this function. Then we write the name of the function. Then equals to. Then we have some capturing variable. Now these can be either ampersand, equals to, or empty. This is something that you can figure it out once you can look at it when you read the article. This I am not explaining. You like many a times I use ampersand only. Okay. Then we can write the parameters. Again, we need to write the parameters again. We need to give an arrow and then the return type and then this curly braces and then a semicolon. This is actually what a lambda function means. You can go to any of the article in GFG and look for it. I don't know it is faster or not, but it becomes faster while writing because I don't need to pass this adjacency matrix to this function, isn't it?
सर जैसे यहाँ पे ये फंक्शन से लेके डीएफएस वाला पार्ट है वहाँ पे ऑटो भी तो लिख सकते हैं ना?
No, since we are writing a recursive function, that's why we can't write auto.
अच्छा ओके.
Yeah, since I am writing a recursive function, I can't write auto. If this would have been any other function other than recursive, I would have used auto keyword over here. This is because I read it somewhere that compiler actually takes some time to identify that what actually this auto keyword is. So when we pass this DFS of IT, it gets confused. It
Okay, sir.
like it can't understand what this auto keyword is. It takes some time. That is something that I wrote and that I read somewhere. Okay, yeah. So what I am writing in this DFS function C, initializing by mini to IE9, going to each and every adjacency node and getting the minimum value from each and every adjacency node. That is something I told you all, that calculate. Wait a minute. Yeah, calculate mini. First of all, from all the from minimum of all the all. Like over here we had two adjacency nodes. So we calculated mini 1 and mini 2, and we are taking mean of those two. So whatever number of adjacency nodes we have, we are taking minimum of all. Now, if the node value is 0, that is, we are standing at the vertex, at the root of the tree. In that case, whatever minimum value we got, what will be our answer? What will be our answer if I am standing at the root of the tree? So whatever minimum value I got, that value plus the initialized value of this root node will be my answer. So if node is 0, I am returning that thing. Otherwise, if the minimum value is still 1E9, I am returning the value of that node. Why? Because if the minimum value is still 1E9, what does this mean? This means that this particular node is a leaf node, isn't it? This particular node is a leaf node. So in that case, I am simply returning the value of that node. Because for a leaf node, we can't do any operation. For a leaf node, we need to return value 3 only. For leaf node, we have to return values as it is. Else, if the minimum is not 1E9, that is the node that I am standing at is not a leaf node. So if the value of the node is greater than equals to the minimum value that I got in its subtree, you can take any large value. I took 1E9, you can take any large value since we are taking minimum values. So if the value of the node is greater than equals to the minimum value that we got, in that case, we are returning the minimum value because we know that we can't increase values more. But if this is not the case, I am returning the minimum value plus the value of the node by 2. So I am simply calling the DFS function at this node 0 and printing the answer. Oh, 1E9 is actually 10 power 9, sorry. So the code is like pretty simple. A simple one DFS call will work. Logic is also not too tough to crack. It was actually on the easier side as compared to the Ds we get. So I hope everyone got it, the code part? Let me